this video, we are going to explain about a project titled Identification of Diabetes Using Machine Learning Algorithms. In this project, we explore the powerful capability of machine learning algorithm to revolutionize the maintenance practice in various industries. By analyzing the real-time sensor data, historical results, and the other relevant parameters, our project aims to predict the equipment failure and the potential issues before they occur. Through the implementation of cutting-edge algorithms such as random forest, LSTM, gradient boosting, we seek to optimize the maintenance schedule, minimize the downtime, and reduce the operational cost. The objective of this project is to perform a comprehensive comparative analysis of 5 machine learning algorithms like of naive-Bayes, SPM, decision tree, random forest, and k-nearest neighbor. For the task of diabetes classification, we aim to train and evaluate each algorithm on the diabetes dataset to determine their strength and weakness in predicting the diabetes outcome. By measuring their accuracy, precision, recall, and F1 score, and other relevant metrics, we seek to identify the most effective algorithm for the diabetes diagnosis. This study findings will contribute the valuable insight into selecting the optimal algorithm for future predictive maintenance, implementation in the healthcare domain, ultimately leading to the proactive and the data-driven healthcare practices. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first step is importing the libraries. Importing the necessary Python libraries like NumPy, Pandas, sklearn, and of use it for the data manipulation, visualization, and the machine learning. And the second one is importing the dataset. Loading the diabetes dataset containing the features like count of pregnancy, glucose, blood pressure, and of many more. And the third one is data pre-processing, handling the missing data, outlier treatment, and the feature scaling to prepare the dataset for the model training. And the next step is splitting into the training and the testing data. Dividing the dataset into the training set and the testing set for the data model evaluation. And the next step is performance analysis. Performance analysis is used to evaluate the performance of each model using the metrics like accuracy, precision, recall, and F1 score. And the next step is model building. Implementing of training multiple machine learning models like of these. The first one is naive-Bayes. Naive-Bayes is a probabilistic classification algorithm based on the Bayes theorem. It assumes that the features are conditionally independent given the class label, which simplifies the probability calculation. It is particularly effective for the test classification and the spam filtering task. Despite its simplicity, naive-Bayes can perform surprisingly well on the wide range of classification problems. It is computationally efficient and requires the minimum training data. However, its assumption of leads to the suboptimal performance in case where the features are highly correlated. And the second one is SPM. It stands for Support Vector Machine, is a powerful supervised machine learning algorithm used for both the classification and the regression task. It aims to find the optimal hyperplane that best separates the different classes in the feature space. SPM can handle both the linear and the non-linear classification problem through the use of kernel function. SPM is known for its ability to handle the high dimensional data, and it works well with the limited training sample. And the next step is decision tree. Decision tree is a popular and initiative machine learning algorithm for both the classification and the regression tasks. It recursively splits the data into the subsets based on the most informative features, creating a tree-like structure. Each internal node represents a decision based on the specific feature, and each leaf node represents a class label or the regression value. Decision trees are easy to interpret and visualize, breaking the for the understanding the model's decision-making process. It's prone to overfitting, especially when the tree becomes too deep and complex. And the fourth is random forest. Random forest is an ensemble learning technique that builds multiple decision trees and combines the prediction through voting. By averaging the output of several weak learners, random forest improves the generalization and reduces the overfitting. It robust against the noisy data and can handle the high dimensional feature space effectively. Random forest is less interpretable compared to a single decision tree, but its overall performance is usually higher due to the variance reduction achieved. And the next one is KNN. KNN is simply a non-parametric classification algorithm that works by comparing the class of the new data point to the class of its k-nearest neighbor in the training data. The class that appears the most frequently among the k neighbors is assigned to the new data point. KNN is easy to understand and implement, making it suitable for the small to the medium-sized data set. However, its performance can be sensitive to the choice of distance metric and the value of k. KNN is also computationally expensive during the prediction phase as it requires searching the entire training dataset for the k nearest neighbor. And the next step is training the model. Here, we training the each model be applied on the modifying the models using the training dataset. And the next one is user gives the input. And here we build an user interface using the class to allow the user to provide the diabetes related information. And the next step is the given input is pre-processed for prediction. Utilizing the trained model to predict whether the user is likely to have the diabetes or not, first we need to pre-process the user input to make it compatible with the trained model. And the next step is trained model is used for the prediction. Utilizing the trained model to predict whether the user is likely to having the diabetes or not. And the last one is final outcome is displayed. Displaying the prediction result to the user indicating the likelihood of having the diabetes based on the input data. And the execution of the project. To execute the project first we need to open the code folder. And this is the code folder containing of various folders within it. The template folder containing of the HTML documents like index and result. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And the diabetes is the CSV file that we used in this project as of the dataset. And this is the pickle file which likely contain the information of the algorithm and that loaded into the project code during the runtime to utilize the trained model for various tasks such as making the prediction on the new data and performing the specific operations. And this is the Jupyter notebook file of IPYNB file which likely contains the combination of graphs and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the disk location to F because our code folder is present in F disk. Then write a command cd space and paste this code folder path. By this it will change the current directory to the code folder's path. And then write a command that is python space app.py. By using this command it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy a link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. And pasting this link, and here it will redirect it to the page containing of the title of the project and some input details that are need to be filled. Number of pregnancies is of 6, glucose level is of 98, and the blood pressure is of 50, and the skin thickness is of 50. and the body mass index is of 24, and the diabetes pedigree function is of 0.34, and the age is of 35. And then click on the predict button. Here it predicted you don't have diabetes. In this way, we can predict the diabetes by using the click on the back button and previous button. Here we can enter the other details too. And I'm giving the number of pregnancies as 6, glucose level as 148, and the blood pressure is of 72, and the skin thickness is of 35, and the insulin level is of 0, and the body mass index is of 33.6, and the diabetes pedigree function is of 0.627, and the age is of 50. And then click on the predict button. Here predicted you have diabetes. In this way, we can predict the diabetes by using the machine learning algorithms. And in conclusion, our project successfully demonstrated the effectiveness of multiple machine learning algorithms, including naive-Bayes, SVM, decision tree, random forest, and KNN in the diabetes identification. Through the rigorous experimentation and evaluation, we identified the most suitable algorithm for accurately diabetes classification. Our findings hold a significant promise for the early detection and the personalized treatment strategy, enabling the healthcare professional to make informed decisions and improve patient outcomes. By harnessing the power of machine learning, our project contributes to advancing medical diagnostics and showcase the potential of technology and transforming the healthcare with the continued research and implementation. We aim to make a positive impact on the life of individuals affected by the diabetes worldwide.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.